Hey guys, Buildzoid here, and today we're going to be taking a look at some rather strange, in my opinion, behavior with the Intel baseline profile on Gigabyte Z790 motherboards. So the motherboard that I'm using here is a Gigabyte Z790 Aorus Extreme X. The CPU I'm using is a 14900K. This 14900K is one of those 14900Ks that literally can't even run Cinebench after a clear CMOS, which is why I'm showing you that currently the BIOS has just been cleared. So the one thing I'm going to do is we're going to set the pump speed to 100%, just to make sure that I have as much cooling as possible, because this chip also, not only is it not stable, it also chugs power, because the vid table for this thing kind of sucks. So yeah, we're going to give it full pump speed so it has as much cooling as possible. The fans don't really, like, it doesn't really matter for the, like, Cinebench R15 finishes in a couple seconds, so it really doesn't matter if the fans are at 100% or not. But the pump does, because the pump is, like, the first thing in the way of the thermal transfer from the cold plate to the, like, the micro fins in the cold plate to the water, right? The faster you push the water through the micro fins, the better the thermal transfer into the water. Because the water is fresher when it comes into contact with the like, you're refreshing the water faster, so the temperature delta is bigger, so the thermal transfer is better. Anyway, this isn't supposed to be a lesson on how coolant works. We're supposed to be investigating how the Intel baseline profile works. So first we're going to run the clear CMOS, right? Like, literally the only thing I changed was the fan speed. So, yeah, we're going to experience what it's like to have a Silicon Lottery loser 14900K first, because this chip is not going to run Cinebench R15 like at all. It crashes very quickly. And there's a few different ways that it can be fixed, but the Intel baseline profile fixes the instability, but it has some weird side effects that I want to show you. Arguably concerning side effects, but unfortunately I don't work at Intel, so I don't know, like, like, at this point I have to hope that Intel has some internal documentation that's, like, better than the publicly available stuff, which they definitely do. But yeah, I don't have access to that, so, like, when I see what the Intel baseline profile is doing, for certain workloads I kind of get concerned. So anyway, here we are in the OS. And so right now we're just idling, so the voltage is pretty, reasonable. We're going to run some single core Cinebench R23 just to show you what kind of, like, voltages we get for a single core workload, because that's the thing that's, like, really wacky with the Intel baseline profile. So yeah, we're going to run single core. And when we run single core, you can see that the core voltage is, like, low, like, it's below, like, 1.4 volts, right? Like, it is very low. We aren't currently getting our 6 gigahertz boost. I think the workload isn't in the correct core. Yeah, I don't think it's on the correct core right now. Give me a second. Set affinity. Should be 7. I'm not sure if it's, like, counting the hyperthreads first or if the E-cores get counted first. Because it's, like, core 6 and 7 that are 6 gigahertz on this chip. Okay, there we go. Now we're getting our, like, are we? Hello? Are we going to run? Oh, it's having issues. Actually, I wonder if maybe it crashed because of it being tied to the 6 gigahertz cores. Okay, I'm going to start it first and then tie it to the 6 gigahertz cores. There, so now it's running. Oh, wait, it's on the 6 gigahertz core, and you can see that our core voltage is jumping up to, like, 1.5 volts, which is high and concerning, but that's not even close to the highest voltage that we're going to see today. Actually, I'm not sure if it's concerning. It's less concerning than what we're going to see later. But yeah, so right now, it bounces between like 1.3 and 1.5 in order to maintain that 6 gigahertz boost on the 6 gigahertz cores on the CPU. Now, if I try to run Cinebench R15, all core, it will lock up any moment. Yeah, there we go. It locked up. So that just crashed. And yeah, the CPU is not capable of running Cinebench R15, so it does that. And there's a few different ways to fix it. The Intel baseline profile fixes it. There's other arguably better ways of fixing it, but we're going to get to those later. And just for good measure, I'm going to demonstrate that, like, yeah, it really does just kind of... Sometimes we'll get an error message, sometimes we don't get an error message. Right now we're not getting the error message. Yeah, and it just locked up again. And you can see that I've managed to run this, in the past, in the, like, back there. So anyway, we're just going to kill that. I also have R23 set up to run on just 4 threads. Again, just for comparison point against the baseline profile from Intel. So if we run 4-thread R23, what kind of voltages we get? We get about like 1.3-ish volts, right? Which is actually quite a sensible voltage, I'd say. And that's to maintain like 5.7 gigahertz on a couple of the cores, because obviously we can't do 6 gigahertz on the 2 6 gigahertz cores while we have other cores loaded to 5.7. So we get 5.7 on 4 cores at the same time, right? And that's just how Intel's Turbo Boost works. So, and for that 5.7 gigahertz on 4 cores, we're basically running at like under 1.4 volts is the best way to describe it, I think. So that's all very well and good, right? So 1.35, around 1.35, below 1.4. Either of those works, in my opinion, as a description of what we're seeing right now. Also, if I try to run... Actually, I'm just going to leave R23 in like quad-core mode. If I run R20, this is in all-core. I imagine this... It might finish, it might crash. Like, R20 isn't as consistent as 15 with the whole... Oh, well, there we go. It won't run 20 either. It's nice. Things are okay. So as we can see, CPU isn't very stable, but the voltages for like single-threaded and all core, like 4-core load, aren't particularly high, right? Oh, I should have shown the max voltage reading throughout that session in hardware info. Oh, well, it doesn't matter. Or at least it doesn't matter that much. Like, look, if you have an Intel CPU, you can check these voltages for yourself. Just download hardware info. At least if you have a Gigabyte motherboard, because I am using the VR-Vout sensor, which is just more accurate for core voltage readings than the V-core sensor that you have on the Super I/O of a motherboard, because the Super I/O V-core sensor measures from like the CPU socket, whereas the VRM V-core sensor measures from the actual CPU itself, unless you have a few, like there's a couple, actually Gigabyte motherboards do have an option, where is it? Oh yeah, you have like V-core Sense, and this is available on like even not that expensive Gigabyte boards, but like I think pretty much every Z790 Gigabyte board will give you the VR-Vout sensor, so you kind of don't really need this. If you have a high-end Asus board, so like a Maximus series, those will have like DyeSense like this as well, to the Super I/O, but I don't think you'll have VR-Vout available. And if you're on an MSI board, you better pray that you have a VR-Vout sensor, because the core voltage sensing on the Super I/O on MSI boards is quite strange. But anyway, yeah, like, so you can basically compare your like voltage behavior to mine if, you think I'm making stuff up or something. So anyway, let's just turn on the Intel baseline, which I am not entirely certain that that's actually from Intel, or if it's like something Gigabyte cooked up, but, if Gigabyte cooked that up and slapped Intel's name on it, I don't think they're going to tell us. And if Intel provided this and it turns out to not be very good, well, I don't think they'll want to own up to it either. So here we are in the OS again. And R15 is going to work now. So that's good. It fixed the stability problems. Amazing. But oh, look at our idle voltage. It's already kind of spicy. It's not the spiciest it's going to be, though. But yeah, we can run R15. So as it turns out, R15 is not a broken pile of garbage software. It's the CPU that wasn't able to run the software. So that's good, I guess. R20 is also going to work now. And while we're running R20, like, you'll notice that, yeah, the voltage is actually quite sensible. But that's because we're bouncing off of a very low power limit, because Gigabyte's Intel baseline power limit is 188 watts. So, yeah, the voltage is very low, and the frequencies are also very low, right? Like, while R20 is running, you can see that the CPU is running at, like, 4.5 gigahertz. It is literally running at frequencies lower than a 7800 X3D, which I find kind of funny. But it is still significantly faster than a 7800 X3D. I should point that out. Like, a 7800 X3D for R20 is like 8,000-ish points, like 7,000 to 8,000-ish points. So obviously, you know, even like if you have 24 cores, even if like more than half of them are E cores, you can be clocked significantly lower and still get a very high score in Cinebench R20. Now, let's run some R23 single-threaded and watch that core voltage. Actually, I mean, let's just check our core voltage right now. What kind of maximum core voltage have we? Oh. Well, it can't get any worse, can it? Ah. Now, I guess I should point out that if we look at the Intel documentation, it does say that the maximum operating voltage is 1.72 volts. So we're technically still below that. But the CPU was running at significantly less voltage before we turned on the Intel baseline profile. So anyway, this is single-threaded. So, you know, you're probably not going to run something that's equivalent to, you know, one thread of Cinebench, because Cinebench is relatively heavy, and it's kind of unrealistic to have a workload that'll actually just, like, sit on one of your two high-performance cores and run them at 6 gigahertz flat out, right? Not a super common scenario, but I think this behavior is already kind of concerning. So let's try 4 cores, right? 4 threads of Cinebench. This isn't going to hit that 6 gigahertz boost anymore, so the voltage should be more sensible. All right, so yeah, we're at 5.7 now, because we're not hitting that 6 gigahertz boost anymore. And the voltage is more sensible, but it is way higher than what we were getting before, right? Previously, it was like 1.35 to 1. Like under 1.4 volts was the like lazy description I gave to that voltage. Well, we are now very comfortably above 1.4 volts. And if I move the mouse around, oh, and honestly, I have no explanation for why it does that. Actually, no, I have a theory for why it does that, but that's not super relevant to the situation right now. So, yeah. Also, that is wild. So moving the mouse around boosts the core voltage, which, okay, but it also boosts the power draw. I was kind of hoping that it was like, at least like, I don't know, nudging Cinebench off of the cores, so it was like reducing the amount of work the CPU is doing, but it's not. Now, like, we have 4 cores burning through 160 watts of power right now. That is something. It is certainly something. I don't really know what to make of this. At the end of the day, I don't work at Intel, so I don't know. Is this actually safe for the CPU? Maybe, but it's definitely way more voltage than what Gigabyte was using before. Um, and we've like already everybody like most of the discussion I've seen on the internet is already accusing the motherboards vendors of degrading the CPUs, but like these Intel baseline profiles are raising the core voltage for everything except power limited workloads. So if you're running something that runs on like anything that's like if you have a workload that doesn't slam into the 188 watt power limit, or I guess actually, and what's kind of funny, I guess if I kept moving the mouse for long enough, it would eventually hit that 125 watt power limit. So I guess eventually it would throttle itself down. Um, that's dumb. But anyway, yeah. So for anything that isn't like super power limited, it actually runs way more voltage. So if you don't use your CPU at 100% very often, the Intel baseline profile is actually going to be running more power into it, at least as far as I can tell. Um, so yeah, that's fun. Um, I don't really know what to make of that. As far as I know, the Asus baseline profile also does something similar, except it uses even higher power limits, which might mean this could get worse. I haven't checked my Asus motherboard yet. Um, I'm not sure if I want to. Um, because I think this whole situation is just stupid. Because, like, what is Intel doing? Um, but, like, the main reason I'm making this video is because I've seen a lot of people accuse the motherboard vendors of overvolting the CPUs. And that's, like, what's causing the stability issues. And, like, there's rumors of degradation. I still have a very hard time believing that Intel would okay, you know, well, okay, actually, maybe I don't have that hard a time believing that Intel would, like, I think Intel would just not bother to check. So it wasn't really about getting their permission when they just don't care. Um, but like you would assume that the reason that they don't care is because they know that the CPUs can take it, or like I don't know. Um, where was I going? Like this is just a horrible mess. Oh right, like I have a hard time believing that there's actual like that the motherboards were like that the current settings from like the default settings from the motherboard vendors were really degrading the CPUs that quickly. Um, especially when I'm seeing like the Intel baseline profile is just running massive amounts of E-core for like single threaded, dual threaded, four threaded workloads, right? Like it fixes the instability though, I guess, so that's something. Anyway, the other thing I wanted to show, oh, I pressed restart instead of shut down. Um, the other thing I wanted to show is like alternative methods of fixing the instability um, with this CPU. Because yeah, like these Intel baseline profiles, like I don't know if they actually come from Intel. If they do, they behave very strangely. Um, honestly, I'm kind of concerned about the voltages that we were seeing here. But like again, the only publicly available Intel documentation says it's fine. Anecdotally, I like, 11th gen documentation says 1.72 volts is fine. I unfortunately don't have 10th gen documentation on hand. Um, I mean, I thought I did, but it turns out I have the freaking laptop CPUs, which use a completely different voltage regulator standard, so that's not helpful in this scenario. Um, but I mean, just the fact that like apparently 14 nanometer in 11th gen CPUs and like Intel 7 uh 14th gen CPUs have the same voltage limits seems a bit sus because like they're drastically different manufacturing processes. Um or at least they should be, like very different. It's not like 14 nanometer plus 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 plus, where funny thing is like like 10th gen and 11th gen are actually kind of unique in having that 1.72 volt limit, or like 1.72 volt maximum operating voltage in the data sheet. Everything before them was 1.52, all the way back to like freaking 32 nanometer Intel CPUs. Actually, I think even 45 nanometer had it set, like had the data sheet at 1.52. So yeah, the voltage, max voltage in the Intel data sheet is like, I am not sure that that really reflects the like capabilities of the CPU's transistors. Um, I've always understood this number here to be more of a like, the motherboard needs to be able to output this voltage, not necessarily that the CPU needs to be able to take this voltage. Um, but yeah, I don't work at Intel, so I don't know what kind of logic goes into their documentation here. So anyway, we're back to clear CMOS, and the funny thing with the Intel baseline profile is if you don't clear CMOS after applying it, it leaves like a bunch of garbage everywhere. So like the board behaves very strangely after applying it once. So uh yeah, like the clear CMOS, if you want to test something else after testing the Intel baseline, is absolutely like a requirement, because I tried earlier to go from Intel baseline to like some custom settings, and they were not behaving the way I expected them to, and then I cleared CMOS and everything worked the way I expected it to. So I guess it changes a bunch of like settings that you can't even see in the BIOS, or I didn't look hard enough. Anyway, um, this board, after a clear CMOS, defaults to a power limit of 280 watts for PL1 and unlimited for PL2, right? So 4,095 watts. And of course, in this configuration, we cannot run Cinebench R15. So I'm just going to quickly prove that. Oh, look it. Oh, wait. Is it? Is it? No, I think it froze again. Oh, it took the whole system down. You'd think a modern CPU could run an application from like 10 years ago after a clear CMOS, but no. No, it can't. That blue screen's taking too long. I'm just going to hit the reset button. Anyway, there's a few different ways to fix it. Probably the most advisable is to just set a current limit. So that's what we're going to do right now. All I'm going to do is I'm going to set a current limit. All right, so BIOS was cleared, which is why R15 was unstable again. Now we're just going to go advanced CPU settings. I'm going to enable the power limits. And I'm just going to max everything except the power limit, except the current limit. And we're going to set this to the Intel. So I also tried 400 amps, and that's actually not stable. But yeah, so as you can see in the Intel documentation, for a wait, the 149, what's the 14900K again? Is it? Give me a sec. I'm just going to pull up Intel Arc. Can't remember Intel's imaginary power limits. Okay, it's 125 watts. So, yeah, 125 watt. Wait, it's 125 watt refresh, isn't it? S refresh, 125 watt, ICC max, 307. So that's where I'm pulling that number from. So we're going to just set that to 307. Oh, I'm going to have to switch R23 to all-core mode. Because doing this actually has a pretty serious performance impact. Compared, well, I mean, like this is the issue is like if your CPU literally can't even finish the benchmark, do you really care about the performance? If your system is randomly crashing and blue screening, is the performance really a concern when you can't even like run software? But anyway, yes, you can see R15 now is able to run. But what's really interesting about this setup, where I have this 307 amp power limit, I mean current limit, is that you'll notice that the CPU package power only goes up to like 258. Which is not really much above the like the Intel, you know, uh, like PL2 that you see on the 14900K product page. It's basically 253 watts, which is kind of fun. That you'd think a 307 amp current limit would, because the voltage we're running at is like when it's running, we're running at like 1.2-ish volts, right? And 1.2, like you'd think if we're hitting the current limit, we'd be pulling at 300 amps, that would be like 360 watts. We're nowhere near that. So the Intel current limit works in like strange ways, and you can actually see that hardware info is telling us that, yeah, we're hitting like ICC max. Even though like you would really think that a 307 amp current limit would, you know, not hit the, like you wouldn't be hitting, you would think you wouldn't hit the current limit until you're hitting like 360 watts of power draw, but you actually hit it way before that. So anyway, yeah, that fixes the R15 stability, and the R20 stability and the R23 stability. Also, we don't have like insanity voltages or anything with this configuration because we don't, right? Like if I run 4 threads, it runs at like 1.3. Actually, it seems to run even lower voltages than, no, it's about the same as the full auto setup, right? And if I move the mouse around, like we're actually pulling less power than the Intel baseline profile was pulling for a 4-thread load because we're running less voltage than the Intel baseline profile for a 4-thread load. It's not really that complicated. And if we run single core, it's basically the same story. Right, like, yeah, the voltage is still quite high, but it's not as high as it was for the Intel baseline profile, right? Like, Intel baseline was hitting up to like 1.67 there. Even with me whacking the mouse around, like, it ain't getting anywhere near 1.67. So the voltages in this configuration are a lot more reasonable than whatever the Intel baseline profile is doing. Even though I have no power limit, and the only thing I've done is set a 307 amp current limit. Now, if I set the current limit to 400 amps, it won't be able to run Cinebench 15 anymore. So, that's one thing. So, one of the concerns here is like, yeah, but I don't know if this 307 amp current limit is actually fully stable, right? Like, okay, we went from R15 doesn't insta crash to R15 actually like R15 was insta crashing on full auto settings, and without full auto settings, it runs for a bit. But does that mean that the system is fully stable? No, because I haven't run like a full exhaustive battery of stress tests for every single possible combination of like load and, basically every single possible combination of load, right? Like you want to test from the lightest workloads to the heaviest workloads, which is one of the like difficulties with modern CPUs that have boost is like you can't just test them at like 100% and well, yeah, you can't just test them at 100%, right? With old CPUs, where you would have the entire CPU runs one frequency all day, every day on all cores, if it can run that frequency in Prime 95 on all cores, it can run that frequency on all cores for any workload. With modern CPUs, that is unfortunately not the case because different workloads will run different frequencies, and so yeah, I don't. And also, there's like a chance that maybe Cinebench R15 works right now for like a few seconds, but it doesn't work for like 24 hours. So if you're doing like 3D rendering or something, this might not be enough to make your system stable enough for that kind of work. So that's annoying. Is like, yeah, this technically fixes the instability, but for me here with this CPU on R15, but is it going to fix your CPU? I don't know. Is it actually fixed completely? I don't know. Like, I need to stress test it extensively, and this is the thing that frustrates me so much about this whole situation is like the whole point of like not overclocking your CPU is that the manufacturer verifies that it's going to work, and then you just stick it in your motherboard and it works. But apparently that's really difficult if you're Intel. Anyway, if I set the current limit back to auto, or actually I'm going to set the current limit all the way to 512. That's as high as it goes. So we're right back to being unable to run Cinebench R15 because there's one other thing I want to show you for fixing the instability. But this one is less safe, this other fix that I'm going to show you. Like the setting a current limit to get the CPU stable, I think that's about as safe as you can really be in terms of trying to fix the instability. The other thing I'm going to show you, well, it basically just raises the core voltage. So on auto, the Gigabyte motherboard defaults to an AC load line of 40 and 90 for a DC load line. So yeah, 4090 for the AC and DC load lines. And now if we try to run R15 with like the no power limits, no current limit, and the default load line settings from Gigabyte, it's going to crash. I'm not even going to bother pulling up hardware info because right now we're just going to make Cinebench crash. That's the whole point of this. And as you can see, it just crashed. Because, yeah, we're not stable right now. So how am I going to fix this? So the other way to fix this, instead of just setting the current limit, is that we have this setting over here called CPU internal AC/DC load line. And if we just set that to turbo, and depending on your CPU, you might have to set this all the way to extreme. But for my CPU, setting it to turbo is enough, at least for temporarily seemingly fixing the instability. I don't know. Again, I haven't run like a full battery of stress tests with this configuration, so I don't know. Maybe there's some workload like Unreal Engine that, it'll crash. But at least for like the quick and easy, verification of like, does this help stability with Cinebench R15? Yes, it does. But basically what that setting that I just changed does is it just gives the CPU more voltage. So basically the whole reason the CPU has been crashing this entire time is it didn't have enough voltage. And that, like, to me, is like, so the motherboard is like undervolting the CPU out of the box. And because, and that's just a bad idea in my opinion. All right, as you can see, like I can actually run Cinebench R15 now. It's not going to crash anymore. Also, we're not going to get insanity voltages for like single-threaded and two-threaded workloads, though for all-core we might actually see some pretty high vCore, I think. because I do have a 360 millimeter cooler on the CPU right now, so it can pull quite a bit of power without before it hits the thermal throttle. So anyway, let's try 4 threads. Oh, I double clicked it. Dumb. So there's 4 threads, and yeah, we're running basically 1.35 again. I mean, it is higher now than it used to be, but still nowhere near as high as it was with the Intel baseline profile. I mean, if I move the mouse around, it actually gets, yeah, pretty high. Still below the Intel baseline profile. I think we saw a little blip of 1.5 for a bit. Wait, where's my core voltages? Oh, only 1.508. Yeah, so this is not doing anything super crazy to the core voltage. Obviously, the power draw is now higher than it was with the auto load line settings from Gigabyte. But the auto load line settings from Gigabyte cause Cinebench to crash, right? So evidently, those don't apply enough voltage. And for single core, okay, so single core is now getting kind of spicy with the core voltage. We're approaching, I think oh no, we still apparently didn't manage to hit 1.6. So, we're still well below what the Intel baseline profile was doing, though we've almost hit 1.6. Still better than the 1.67 that the Intel baseline profile decided was a good idea. Anyway, I'm going to stop that, and we're going to switch R23 to all-core. And we're going to do an all-core test. You can see the core voltage is down to 1.3, and we are thermal throttling because the CPU is pulling 340 watts. And we get 39,943 points. If I close hardware info, that should actually go up a bit, because I do have hardware info set to 500 millisecond polling so that we get more voltage updates. Because the thing is, modern CPUs are capable of adjusting their core voltage very, very quickly. So even at 500 milliseconds, we're not really seeing everything that's happening, but it's better than the default 2-second update rate, also known as 2000 milliseconds. Okay, so that's about as high a score that I can get out of the CPU. It's not actually really, earlier today when I was doing pre-testing for this video, I actually managed to somehow get a 40,900. But I guess the, cooling loop is, warmed up or something at this point. Anyway, so, yeah, that's an alternative way of fixing the instability. I'd say this one's a lot less safe than just setting a current limit, but the thing is, when you just set the current limit, it actually, it lowers the performance more than what I just did. Also, what I just did, if we look into the VRM settings, right, so I just set this to turbo. There's also an extreme option, but on turbo, what that does is it basically sets this to 70. And that's enough to fix the instability. And that technically is still within Intel spec, because if we go to the Intel documentation, right here it says load line slope. So we have DCLL and ACLL. And ACLL maximum, right? Maximum value is the same as DCLL. And if we go back to the motherboard, you can see that DCLL is set to 90 and ACLL is set to 70. So it's below the DCLL, so that's still in Intel spec. And the DCLL is still below 1.1 milliohms, because the 90 is 0.9 milliohms. So we're still below the 1.1 milliohms that Intel specs as a maximum for the DCLL. Um, so, like, technically the settings I'm running right now, I mean, obviously the current limit is set through the roof, but we're in the, like, the load line slope specs, and right now, actually, what I could do is, if I go back here, and this previously wouldn't work, is, like, I could set the current limit to, like, 400 amps, which on, like, if I didn't have the AC load line set to 70, that wouldn't be stable. I mean, I haven't shown it here, but, like, in earlier testing, 400 current limit, like, wouldn't be stable. So, yeah. That's, like, a thing. Um, anyway, what did I want to do? I mean, I guess we could check what the 400 amp current limit does right now. I mean, I'm still going to keep the load line adjusted. Because it's necessary for stability. I'm just kind of wondering, like, what'll happen to the performance if we set this to 400 right now. It might even go up, because the CPU might thermal throttle less. Not 100% sure what'll happen. Oh, there we go, 40,465. So yeah, I guess the water loop was just warmed up from the other testing. And 15 still works. Yeah, so that all works. Anyway. So now we're gonna check what the Intel baseline profile does to stability, like to performance. It's not good. Also, I'll show you what the Intel baseline does to the AC load line and the DC load line, which is arguably less good. Anyway, I forgot that yeah, we ideally want to clear CMOS again before we load up the Intel baseline. I'm just going to clear CMOS. All right, just load up Intel baseline. If I remember correctly, this should spit out about 35,000 points. Or like 34,500 points. And of course, give us absolutely insane voltages for anything less than 100% load. Okay, that's not true. For anything less than like 10% load. Actually, 4 cores out of 24 is more than 10%, isn't it? Yeah, it is. It's like 15-ish, 20-ish. Actually, yeah, it's like between 15 and 20%. Because 20% would be like 4.8 cores on a 24-core CPU. Anyway, let's just run Cinebench R23. Without hardware info, obviously, so that it doesn't affect the score. Yeah, 34,500 points. So, you know, if we do some basic math on that with a calculator, 34.5 divided by 40,000 point... You know what, we'll just go with 40,000 because, you know, like most of the time the CPU doesn't do 40,400 points or more than that. So we'll just go with 40,000. So that's like a 13%, like 13.75% reduction in performance. Not exactly the end of the world, but also this is at this point slower than a 7950X. Because off the top of my head, the 7950X is like 38,000-ish, something like that. And again, Gigabyte seems to have the most aggressive like Intel baseline profile in terms of setting the PL2 really, really low. And you know, since we're already in the OS, like again, I just want to show like this Intel baseline thing, it sets insane core voltages for low load. I realize that, you know, if we go back to that Intel data sheet, it does say 1.72 volts. We've technically not violated that. I'm not sure if we haven't, though. I'm not so certain that we haven't violated the functionality of the CPU at this point, especially on the 6 gigahertz cores. I imagine they're very appreciative of being run at like 1.6 volts. Oh, apparently we managed to get them to even like hit 100 degrees. I really can't imagine that this is good for those cores. Right? Because like we are absolutely, yeah, we're just torturing core 6, which is one of the 6 gigahertz cores on the CPU. Yeah, if I start moving the mouse around, can I get the temperature to shoot through the roof again? Not really, I guess. Yeah, so not, like, I am not sure what to make of that. And there was, what was it? Oh, right. The last thing I wanted to show you is like where that massive core voltage increase comes from on the Intel baseline profile. At least for Gigabyte boards. As far as I know, the Asus boards behave pretty similarly with this. But I haven't checked my Asus motherboards yet. I mean, well, I technically do have several of them, so it's not just one. But anyway, yeah, if we go to the advanced voltage settings and the internal VR control and then turn this on, that's 170. That's 1.7 milliohms. If we go consult the Intel documentation, that's the spec for 35-watt CPUs. Not 125-watt CPUs. So I really don't know what's going on with that. Like, maybe the Intel baseline profiles aren't from Intel. Or they are from Intel, and Intel is recommending settings that aren't like go against their own documentation. Neither of those is a very good, like neither of those is a good thing, right? If the Intel baseline profile isn't actually from Intel, then like Intel evidently hasn't given the motherboard vendors any instructions on how to fix the issue, and they're just cooking up whatever. And if these profiles are from Intel, then Intel either their publicly released specifications are wrong, uh, or Intel doesn't even know what they are. Right? And by that I mean like this apparently isn't high enough or something. Cuz like, yeah. So this whole situation is just a horrible mess. And also, considering the fact that like I can fix the instability with no power limit by just setting this to turbo, which again, I don't know if that's actually safe for the CPU. But it does fix the instability, and it technically doesn't go out of the Intel specification for the load line. Right? So that. So you would maybe think that it would probably be safe, but I'm not so sure. Ultimately, I still think that this whole the instability is less about degradation and much more about the motherboards basically undervolting the CPU out of the box. Right? Because the Gigabyte default for these two settings here is 40 and 90. And that gives you less voltage than 70 and 90. Right? Like slightly less voltage than 70 and 90, which is why it's not stable in like Cinebench R15 or R20 or R23 all-core, right? And then compared to the Intel baseline, it's a lot less voltage. Like, it's massively less voltage. It's like not even in the like. So, yeah, the fact that like if I want to fix the instability on my CPU myself, like I have two options. I can either set a current limit of like 307 amps, and again, I'm not, I don't know if that actually completely fixes all of the instability, but at least it fixes Cinebench R15. Or I can just raise the AC load line to 70. Like, to me, that really indicates like the CPU just isn't getting enough core voltage under load. So the instability is caused by the basically too much undervolting by the motherboard. Not like the motherboard wasn't overvolting the CPU, it was undervolting the CPU, and that's why it was crashing. Now, you could argue that the motherboard was overpowering the CPU, right? Because it didn't, like, out of the box, there was no current limit. The power limits are sky high. But I don't think you could argue that it was overvolting the CPU, because it was, like, the stability gets better if I give it even more voltage. And we're not, we're not above the Intel specification for the load line, even with the extra voltage that I give it. So, yeah, and I think the instability, especially on CPUs where they're unstable right out of the box, I think the like most direct cause of that is this statement right here. Right? Because a superior board design with a shallower AC load line can improve on power, performance, and thermals. Nowhere does it mention reliability or stability compared to boards designed for POR impedance, right? And so if you're a motherboard vendor, this is just like encouraging you to set the AC load line setting as low as possible. And if you screw up, it's going to cause CPUs to randomly crash. Right? If you set it too low, CPUs won't be stable anymore. And now, according to Intel, this is supposed to be set based on measurements using a tool, but that assumes that the tool is accurate or that the people using the tool actually care about what the tool tells them to do, right? Because just because the tool says, hey, your motherboard should be set to 7090 doesn't mean somebody can't just decide, yeah, but I want to set it to 4090. So, I don't think this is the kind of thing you should have in a specification if you care about stability. because encouraging your freaking board partners to undervolt the CPUs as much as they think is possible does not tend to lead to stable operation. Yeah. And then the other thing is, like, I don't get why the Intel baseline loads up like a 1.7 milliohms of load line. That's why the voltage is so damn high. But, like, where is Gigabyte getting this number? And why? It honestly makes me wonder if, like, the Intel baseline profile that, like, Gigabyte has here, like, does, like, sure, it might not degrade the CPU at all core load because the power limit is 188 watts, but, like, is it going to just destroy your 6 gigahertz cores? Because, like, it's running them at, like, 1.6 volts. Actually, we even saw 1.67, right? Depending on what you're doing with your 6 gigahertz cores, like, it's running way more voltage than the motherboard would if you just didn't enable the Intel baseline profile. So it's definitely doing more damage to those cores than not using the Intel baseline profile. And sure, the Intel baseline profile is stable for Cinebench R15 and stuff, but, like, you can fix that by setting a very low current limit. Like, maybe your CPU is even worse than mine, and setting the current limit to 307 still crashes in Cinebench R15. Well, you could set it to 250. You could set it to 200 if you're extremely desperate. I think at that point your CPU is going to be very, very slow. But at least you wouldn't have to, like... And like, it would probably still be better than the Intel baseline profile because you're not cranking up the core voltage. And... Well, and the Intel baseline profile does have a very low power limit of 188 watts. Yeah, so this whole situation, like, this is just a horrible mess, as far as I'm concerned. Because, like, the Intel baseline profile, like, it fixes the all-core stability. It arguably improves on the for all-core load, it does kind of lower the voltage. But for low loads, it slams the voltage. Like, this is, I don't really think you could ever get, like, it's ridiculous. Like, this is, it's hitting like 1.65 volts running one thread of Cinebench. Like, that's insane. Also, it, like, drastically degrades performance compared to, like, setting a 300 amp current limit or just, like, raising the AC/DC load line a bit. I mean, mainly just raising the AC load line. I didn't even have to touch the DC one. But the thing is, like, I don't know if it's safe to raise the AC load line. Oh, and I guess that brings up the point about the degradation. Because the thing is, I still have a very hard time believing that Intel would be shipping CPU, because here's the thing, like, the motherboard vendors don't want to intentionally break your CPU, right? That's not really, like, if you sell motherboards, and your motherboards get a reputation for breaking people's stuff, people aren't going to want to buy your motherboards anymore. Okay, that is bad for business. But if if the CPU supplier gives you garbage instructions on how to implement your motherboard, and you accidentally end up killing people's CPUs, I can totally see that happening, right? That was kind of the situation with the, like, SoC voltage on AM5, where if you wanted to run, like, DDR5 6400, a lot of CPUs would require, like, 1.4 volts of SoC voltage. And at the time, there wasn't really a whole lot of evidence that that is going to kill CPUs. Because it actually takes a while to break most chips. Like, a lot of CPUs will tolerate 1.4 SoC for a very long time before it becomes a problem. And so, at, like, on launch day for AM5, the assumption was like, yeah, you can, you want to run DDR5 6400, you just set the SoC voltage to like 1.4 volts and it'll work. And then it turned out several months later, once, like, because the funny thing is, like, everybody pays attention to the 7800X3D failures, but there was already, like, dead 7900Xs from SoC voltage. So, like, this affected all of the CPUs. It's just that it got the most attention once the X3D chips showed up, which might be because they were more popular or something. I don't know. Maybe they're just more susceptible to the SoC degradation or something. I don't know the full story behind it, but at that point, AMD like actually went and investigated, and they were like, "Oh, this is a bad idea. We shouldn't, And so they went and just made sure that no motherboard at this point it will easily like allow you to set this SoC voltage above 1.3 volts. And meanwhile on Intel, it's like first, Intel just doesn't care about enforcing power limits, historically speaking, right? Like, that's just been a thing with Intel motherboards for a very long time, that, like, the power limit is whatever the hell you feel like. Recently, they've added this whole, like, hey, you can, like, lower the AC load line. And it's like, so I find it, like, I don't, so when it comes to the degradation side of it, it's like, if the CPUs are degrading, I am blaming Intel. Because, like, if you have internal documentation where it's like, hey, if you do X to our CPU, it will die, and you don't tell your board partners that, why do you even have that information? Like, why did you test? Why did you conduct those tests? Why don't you provide that information to your board partners so that they don't break CPUs? Right? And so the other option is like, oh, maybe their data is wrong, or they don't have it, which is really concerning. So yeah, like, to me, this whole situation is like with the SoC overvoltage issues on AM5, I primarily blame AMD for that. And with this, I primarily blame Intel. Because, like, look, you make the CPUs. You should know what they can tolerate. It's basically your job to tell your motherboard manufacturers, what those tolerances are. And if you don't do that, then they're going to break stuff. Like, it's kind of hard to design a BIOS for a CPU if you don't have the appropriate documentation for it and the proper guidelines for it, and yeah, and the thing is, like, I've not seen any evidence of the motherboards like overvolting the CPUs, because the AC load lines are below the Intel spec on like default settings. They're so low, in fact, that they cause the CPUs to crash. Historically, Intel never cared about the power limits. I think the only thing you could accuse the motherboard vendors of doing is ignoring Intel's current limits. But even those aren't like super clear, because like, yeah, we have this 307 here, but then there's this extreme config, and it's like, well, what's that? Actually, I guess we could read the notes. 4, 5, 6, 7, 1, and 17. Designed to support this current. 4, 5, thermally support this current indefinitely. 7, long-term reliability cannot be assured in conditions above or maximum minimum functional limits. ICC 400 amps is a optional extreme power delivery spec which opportunistically allows better multi-core performance based on customer design's power delivery if thermal headroom exists. Yeah, but my CPU will not, like... My CPU, like, straight up crashes if I set it to 400 amps. So I guess you could say that, hey, the motherboard vendors weren't enforcing that 400 amp current limit. But even on that on that 400 amp current limit, because there are motherboards that just don't have a current limit. Gigabyte motherboards, for example, they don't have a current limit out of the box. But even on that 400 amp current limit, like my 14900K will still crash. And my 14900K doesn't get a lot of use because I don't like this CPU very much, if you can't tell. So I kind of don't think my CPU could be that badly degraded, considering that I've not really run it that long. I mean, I run a lot of Y-Cruncher on it, but that was with a 240mm AIO, so it would usually throttle before it hit 300 watts of power limit. I mean, 300 watts of power draw. It would usually like power thermal throttle at like 260-ish or something. So yeah, I guess you could say they were not enforcing the current limits, but I don't think you could accuse the motherboard vendors of overvolting the CPUs. At least not until they implemented the Intel baseline profile, because man, the voltages that runs. Though again, technically in spec. Because 1.67 volts, while it sounds extremely high, is still less than 1.72. So yeah, I am like, I blame Intel. Like, they design the CPUs. They produce the documentation for the CPUs, and like, it would be one thing if it was really clear that the motherboard vendors just like are way outside the Intel documentation, and for technically for the current limit they are. Some of them, maybe all of them. I'm not sure. But for the power limits, like Intel actually just straight up doesn't care because like their power limits are a recommendation, not a requirement. So I don't really see that being like, oh, you're, like, I don't really see that as a issue. And historically, Intel really hasn't cared, right? Like for 8th gen, 9th gen, 10th gen, it was just like run whatever power limit you want. I don't remember if they had a similar like AC DC load line spec thing for those. Actually, with 12th gen, they also didn't care, right? Like, you don't hear Intel going like, oh, Intel 12th gen was supposed to run at whatever power limits. Oh, apparently that 1.72 volt thing was already with 8th gen. See? Interesting. Anyway, so we had a bunch of current limits for those that I don't think anybody followed. And we still had the same thing. So I guess the benefit was that these CPUs just didn't try to boost as hard. So this is like the same thing they have as in the latest documentation. I wonder when they added that. Now you'll also notice that the load lines for like the old Intel CPUs were like a lot, maximum load line was a lot I guess deeper than what we have on the newest ones. But then again, like Gigabyte is way below the 1.1 milliohms, right? They're at like freaking 40 for the AC load. Like they're at 0.4 instead of 1.1. And 0.4 is not stable, as I've shown here. So Anyway, yeah, I don't really know what to make of this situation. Like the Intel baseline profile that like we have on Gigabyte is like is it safe? Maybe. Is it from Intel? I don't know. Is it from Gigabyte? I don't know. Um, the core voltages that it ends up at for like lighter loads are arguably concerning, but like again, like maybe it's fine. Like the Intel documentation has 1.72 volts in it. I don't know how much I would trust documentation from a, like how much I would trust this documentation considering that like we have widespread stability issues on these CPUs. Seems like something somewhere wasn't properly documented if, So, um yeah, I like it's a mess. It's a horrible mess. Um But I'd say like it ultimately it originates with the CPU manufacturers because like they need to tell the board vendors what to do. Um, and like yeah, and if and like I still and I should just end this video. It's like freaking 4 a.m. and I'm actually it's way past 4 a.m. It's like 5 a.m. That's why I'm losing it at this point. So I'm just press the wait. No, I need to do the outro. So hopefully this was at least somewhat interesting, if not particularly useful. Um, and I guess thank you for watching. Like, share, subscribe. Leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking. There's a Patreon. There's a link to that down in the description. I have a Teespring store. There's like shirts and hoodies, YouTuber merch. And I've also got a Bandcamp. There's a link to that down in the description below as well. And yeah, I'm a go sleep because I no longer functional mentally. So thanks for watching and goodbye.